So the goal today is to summarize what we learned in class. When we started in class, we were given this equivalent fraction and number line chart, and you filled it out, and it should be glued into your notebook. And in doing so, you have a nice set of number lines that show a lot of equivalent fractions. I'm going to demonstrate how you can use this as a tool, along with the ratio table, to find equivalent fractions or fractions close to a given number. So, in your notebook today, if you didn't get a chance to write notes down, this would be a good time to follow along. One of the directions was to name 3 other fractions equal to a half, and then do the same process. So we could call this problem 1, and this part A, part B, and part C. So we're going to name 3 other fractions equal to each one of these fractions. And the first way I'd like you to do that is with this chart over here, because this chart here gives you a nice conceptual understanding or a nice visual picture of what it means for fractions to be equal. For example, if I take this point 1/2 and I draw a nice straight line down, it crosses right over several other fractions. So since 1/2 lines up with 2/4 and 4/8 and 5/10 and 6/12, all of those are fractions that are equal to 1/2. So we could write them down. 1/2 is equal to 2/4. It's also equal to 4/8. 1/2 is also equal to 5/10. And it's also equal to 6/12. Another pattern that people observed in class was the way they tell if a fraction is 1/2 is if the top number is just half of the bottom number, or in other words, if you take the top number, like 6 in this case, if you could just multiply it by 2 and get the bottom number, anytime that happens, your fraction is 1/2. So this tool over here, it's a nice visual to find equivalent fractions. We don't want to forget, however, that there's so many more fractions equal to 1/2. In fact, there's an infinite number of fractions equal to 1/2. And a good way to find other fractions that are equal to 1/2 would be to continue working with our ratio table tool. So I'm going to set up a ratio table here. And I'm going to set up the ratio table with this fraction 1/2. Put it right in my ratio table. So even though we're talking about fractions, we can treat this like the ratio 1:2. And in addition to getting all the equivalent fractions that I have up here, there's so many other things that I might be able to do, like multiply by 10, which would give me 10/20. So 10/20 is equivalent to 1/2. Or I could double, or yeah, double. So this would be 20/40. And just to practice those ratio table skills, don't forget that you could go back to the original column and maybe triple. And so we would get 3, when I triple down here, 6. That's another fraction equal to 1/2. And then the last skill I want to have you continue practicing is you can also add columns. So I can add this column to that column and come up with another equivalent fraction. So 13. So I add the top, the numerators, and then I add the denominators, 13/26. Those are all examples of fractions that are equivalent to 1/2. So we'll repeat the process with 2/3 with the picture. So if I look at the picture, I can find on this chart, from this picture, I can find that 2/3 is equal to, down here, that says 8/12. Unlike the half, I didn't get a lot of equivalent fractions from that picture. But if I need more, I can always employ my ratio table. So here's my ratio table tool. And so I'll put it right there. So if I want to find other fractions equivalent to 2/3, I'll just build it in the ratio table. Maybe I'll multiply by 5. That's an easy math fact, so this is 10/15. Or maybe I will triple, and that would give me 30/45. All of these are equivalent fractions to 2/3. And again, don't forget, whenever you use a ratio table, you can add columns. So when I add those columns, I get 40, and 45 plus 15 is 60. So 40/60ths is another example of an equivalent fraction. In other words, 2/3 can be equal to all of those. 2/3 is equal to 8/12, which is also equal to 10/15. I took that from my ratio table. It's equal to 30/45, and it's equal to 40/60, and the list could just go on and on. But for right now, we're going to stop there. Another good one for you to practice would be 4/5. You should try that one on your own. The next thing that we talked about in Investigation 1.3 is finding fractions that are near but not equal to. We also had a little bit of homework like that last night, because this is a elementary school review topic. But just in case you need a review, all of the fractions that are equivalent to 1/2 line up with that yellow line. But I could find a fraction that's near 1/2 but not equivalent to. For example, I could say that 5/12 is close to 1/2. So near to 1/2, but not equivalent to, could be 5/12. Okay. If we look a little farther up on the number line, we'd say 4/10 is also pretty close to 1/2, but not exactly at 1/2. There's lots of different examples that you can do there. For example, if we use our information from here, another fraction that's near to 1/2 but not exactly 1/2 would be 9 out of 20, 9/20ths. Because if we look over here, 10/20ths is exactly 1/2. So just a little bit smaller than 10/20ths is 9/20ths. We can repeat the process without the picture, just looking at the ratio tables. For example, we call that problem 2A, and look at problem 2B. 2/3, down here, we have lots of equivalent fractions for 2/3. 8/12 is equal to 2/3, so something that's near 2/3, but not equal to 2/3, would be, instead of 8/12 over here, we would say 7/12, or maybe 9/12. So those are examples of fractions that are near to 2/3, but not equal to 2/3. And again, Here's a one for you to practice yourself. The last concept that I want to summarize from class today is the concept of distance between 2 points on a number line. And when you think of distance, think about how many jumps there are to get from one number to another. For example, if I want to find the distance between 0 and 7/10, I'm going to start with my equivalent fraction chart here and look for the tenths. And then I'm going to put my pen at 0 and just count jumps until I get to 7/10. So that's 5 jumps, 6 jumps, 7 jumps. So for most of you, that's a very straightforward problem. But I like to start with an easy problem to make sure we understand the meaning of the word distance. So you could just think of it as how many jumps there are between the two numbers and how big the jumps are. So in this case, there were 7 jumps, and each jump was the size of a tenth, because that's how big the first jump is. If I wanted to find the distance between 7/10 and 1, then I would repeat the process, but now I'm going to start at 7/10 and I do 3 jumps. So now the distance between 7/10 and 1 is 3 jumps, each jump being the size of a 10th jump. So when you look at a problem like this problem here, the distance between 3/5 and 7/10, that technique doesn't work quite as well because 3/5 is on one number line and 7/10 is on the other number line. But you may notice that 3/5 is the exact same number as 6/10. It's an equivalent fraction. If you didn't notice that on the number line, you can also take your 3/5 and use a small ratio table and just multiply the denominator by 2 so you can get the 5 to become a 10, and then you would do the same thing to the numerator, and you could show yourself that 3/5 is equal to 6/10. So 6/10 is an equivalent fraction. So to answer the question, we could just figure out the distance between 6/10 and 7/10. And of course, that is just one jump of size 10. Because between 6/10 and 7/10 is just one jump, and the jump is the size of 1/10. The last problem is the same concept. It's a little bit bigger challenge. So we want to figure out the distance between 1/3 and 5/12. So 5/12 is right here. Let's change the color of that. 5/12 is here in red. And 1/3 is up here. So with the picture, I can also see that 1/3 is equal to 4/12. But if I wasn't able to use a picture, I can take 1/3 with the ratio table and change it so I get a 12 in the denominator by multiplying by 4. So this is 4/12. So now I'm going to just find the distance between 4/12 and 5/12. And when I do that, there's only one jump, but now it's not the size of 1/10. It's the same size as 1/12. So we say the distance between 4/12 12ths and 5/12ths is one jump of 5/12. So the distance between 1/3 and 5/12 then is also 1/12 apart.